So the first thing I want to do is specify the state of the application. This is generally a good first place to start when you're thinking about overall design and smart contract development. And in here, I have a couple of things that I know I want to save to the application as a global state value. And so, much like in our session two, we had a app with a counter and we initialized a class that had the counter in it. Here, we're initializing a class called auction state, and then we define some properties on that class to define what our global state values will be. So our first value here is going to be highest bidder. And you might notice this final piece is new compared to last session. What this is basically doing is telling MyPy or the Python type checking that this highest bidder property must always be a global state value. We set the value to global state value, and that value is then final. So we can change the value of it, but we cannot change the type of it. So this basically means highest bidder is always pointing to a global state value. And in our case, we want to initialize our global state value with a couple of options here. The first of which is telling the compiler what kind of data am I saving in this global state value. And in our case, highest bidder is going to be saving the address of the person that is currently winning the auction. And so we have two options in global state. We have bytes for UN64, and addresses are going to be bytes. So we're specifying stack type as field type dot bytes. And then we also want to specify our default value. In our case here, we're setting default value just to an empty string. Again, always remembering to initialize the bytes class whenever we want to represent on-chain strings. If we just passed in the string without the bytes, then the compiler won't know what to do with the Python string. It only knows what to do with PyTeal bytes. And finally, just a description of our state, and that's going to be the address of the highest bidder. So that is our one value that's going to be bytes, and then our rest of our value will be UN64s. Here we have our auction end, which will be a timestamp corresponding with when the auction should end. Have our highest bid, which is the amount of the highest bid. And whenever we're developing on Algorand, we're always working in micro algos or U algo. So 1 times 10 to the negative 6 algo. And so we're going to be saving that here in highest bid. We have our ASA amount. This is saving how much of our asset are we actually auctioning. So in the case of an NFT, this is always simply just going to be one. However, if you have a fungible token that's being auctioned, you want to specify how much of that fungible token is being auctioned because you don't want some people to think that they're placing bids for one, where others think they're placing bids for 10. You want that to remain static throughout the entirety of the auction. So we're going to do that here. It's a total amount of ASA being auctioned. And then finally, this ASA key, it's going to save the value of the ID of the ASA being auctioned. So on Algorand, whenever we create an asset, so whether it's a fungible token or an NFT, it has a unique 64-bit identifier. And this is where we'll be saving it here in this ASA key. You might notice all of our integers have this default equals and 0 value. So this means that our default values for all of our integers are going to be 0, and then our address is going to be empty. So now we've defined our global state. We can go ahead and instantiate our application. So here we're doing app equals application, and this application is coming from Beaker. And we're passing in the name of our contract. In our case, this is going to be auction. And we're passing in the class that defines our state. So in our case, that is auction state. So now what we do is we have this empty contract that Beaker knows it has some state, but we need to define our methods. So we're going to go down here to line 44 and create our first method. And this is going to be the method that's used to create the contract. And we signify that via this at app.create decorator. So the at app signifies we're attaching the method to this app. And then the dot create tells us that this is going to be a method to call when we create the application. And what this true is doing, it's basically saying whenever we want to create the application, we don't have to specify the name of the method. we know that whenever we create it, this is the method we want to call. We don't have to manually specify the name when we call it. So that's what the bare equals true is doing. And so now into the actual logic of our method, we just call it create. There are no input arguments, so we can have it as bare. And then all we want to do is when we create it, initialize our global state. So to do that, we have this handy helper function app.initialize global state. What this will do is basically iterate over all of our global state values and set them to the default value. So when we call app.initialize global state, I'll go ahead and set all these integers to 0 and set our highest bidder to an empty byte slice. And so that's just it in the create method. We're not doing anything extra special there. So now let's go into our first actual method. So the first thing we want to do as part of our contract logic is allow the contract itself to opt into the asset. So on Algorand, in order to receive an asset, account has to explicitly opt in. And that's not only true for regular end user accounts, but it's also true for smart contracts as well. So when you create a smart contract, it has a unique 64-bit integer to identify it, but then it also has a unique address that it can send and receive transactions to and from. So what we want to do is tell the ledger that we want that address to be able to receive our asset that we want to auction. So we have this method called opt into asset, and our goal here is to opt the contract address into the asset. Now, before we go into the actual method, let's talk a little bit about this at app.external method. What this is doing is much like our create. This at app portion is saying attach this method to our application. And this dot external is saying that this is a public method. We want this to be exposed in our ABI. So we want to be able to tell people how we call this. And we want this to be publicly callable. We don't want this to only use this internally. We want to use this publicly by anyone that has access to the chain. But the exception to that is that we want to add some specific authorization code. So in this case, we don't want anyone to be able to opt the contract into an asset except for the creator. And the reason we're doing this is because we don't want someone to create an auction contract and then someone else basically snipe the contract and take it for their own auction, because then at that point, the original creator will have to create another auction. And so we want to make sure that it's only the original auction creator that has the ability to call this option to asset method. And so to do that, we pass in this authorize only, and then we're passing in our global creator address. That's basically saying only authorize this address, which global.creator address maps to the address that created our application. And so now we're going to define our opt into asset method, and we're going to pass in one argument called that is an ABI asset. What we're basically doing here is calling this method and telling the method which asset ID we need to opt into. So now let's go into our actual logic. So again, every method must return an expression. In our case, we have multiple expressions that we want to execute on chain. So we're going to use a sequence to tie them all together. And let's take a look at our first expression here. What we're doing here is the first thing that you basically always want to do when calling a method. This is a very common pattern when running smart contracts, is before you actually do the things you want to do, make sure that the contract state is as you expect it. So what we're basically doing here is later on in this code, we're going to be setting our global state value, our ASA state value. So what we want to do is make sure that we haven't already set it. So in our global state, we have this key called ASA, and that's going to hold whatever ASA we're auctioning. And in this step here, what we're doing is we're calling assert to make sure that the app state.asa key is 0. In other words, we're making sure that this ASA global state value is still the default value and we haven't changed it. And the reason we're doing this is to make sure that the contract is only opting into one asset. We don't want it opting into multiple assets because we're only going to be auctioning off one specific asset. So that's what we're doing here. Again, the common pattern is before you do the things you want to do, make sure the state is as you expect it to be in your contract. So now that we've verified the state as we expected, we can go ahead and update the state. So now what we're going to do is we're going to say app state asa.set. So we're setting the value stored in this ASA key, and we're going to set it to the asset ID of the asset we passed in. So this will be a UN64 that is unique to the asset we want to auction off. And now finally, we can actually opt into the asset. So we covered this in session one. And so just a reminder, when we want to opt into the asset in a contract, you just send a inner opt-in transaction, and an opt-in transaction is simply a zero asset transfer from one address to itself. So in our case, we're sending an inner transaction, which basically means the contract itself is sending the transaction. So on the ledger, this transaction is coming from the address of the application rather than the address of the person that called it. And so what we can do here is use our inner transaction builder execute function to execute an on-chain transaction. And we're going to say type enum. This is always the first thing you want to do with transactions. Specify what type of transaction it is. And here we're going to specify it's an asset transfer. And then we're going to specify the fee. So in smart contracts, whenever we send an inner transaction, we basically always want to set the fee to 0. So that way there, the end user, so the person that's calling this opt-in to asset method, is the one that worries about the fee. Otherwise, we would have to manually fund the contract with the fee amount, and that can be a little bit annoying. So instead, Algorand has this concept of fee pooling. So we can go ahead and when we call this method, which we'll be showing a bit later, we're going to double the fee here and set the fee to 0. So our total fee will be able to cover everything. Now, what we're doing is setting the asset receiver. So you might notice we don't specify a sender field, and that's because the sender is implicitly the address of the contract itself. So when we send an inner transaction, if we don't manually override the sender fee, it's always going to be the address of the contract. So here in our receiver, it's global.current application address, which, as you can guess, returns the current application address. So what this is basically saying is it's doing an asset transfer from current application address to current application address. And then we're specifying the asset and then setting the amount to 0 to specify that we're doing an opt-in transaction. So now someone will call opt-in to asset and it must be the creator address. And at the end of this function, the contract will send its own transaction to opt in. And now it is able to receive the asset.